When we talk about consecutive integers, we're talking about numbers like 5, 6, 7, and so on, or -18, -17, -16, etc. Okay, those are consecutive integers. They differ by 1. So we can also represent those algebraically. If we let our first integer be n, then our next integer can be represented by n plus 1. Our next integer can be n plus 2, etc., etc. So we could keep going with that. So notice that works in both of these examples. If -18 is my n, then to get to -17, that's -18 plus 1. To get to -16, that's -18 plus 2. So that's how we represent consecutive integers. Now we can also talk about things like consecutive even integers, okay, which would be things like, let's just write this, consecutive even integers, okay, would be things like 4, 6, 8, 10, or things like 22, 24, 26. Okay, those are consecutive even integers. So you're going to start at an even integer and you're going to go on to the next one. And so we can represent those algebraically with n being our first even integer. To get to the next even integer, we do n plus 2. Okay, to get to 6 from 4, we add 2. To get to 8 from 6, we add 2. So each step we're going to add 2. So now this one's going to be n plus 4. And we could keep going, n plus 6, n plus 8. So that's how we're going to represent consecutive even integers. We can also talk about consecutive odd integers. Okay, so things like 3, 5, 7, 9, etc. And same thing there, if n is our first integer, to get to the next odd number, we're always going to be adding 2. So n plus 2, again, n plus 4, n plus 6, etc. So that's how we represent consecutive integers. Okay, so this was consecutive integers. And consecutive even integers and consecutive odd integers. So consecutive integers only differ by 1, whereas consecutive even and odd integers differ by 2 each time. So now let's look at solving a problem involving these. 5 times the smallest of 3 consecutive odd integers is 7 more than twice the largest. Find the largest integer. So since we're dealing with, we have 3 consecutive odd integers, okay? So we can say n is the least of our integers, okay? So if n is our first integer, first odd integer, our next odd integer has to be n plus 2. And our next one has to be, our largest has to be n plus 4. Let's write that, n plus 4. Okay, so these represent, we have 3 consecutive odd integers. Okay, So they're going to be n plus 2, and n plus 4. So we know that 5 times the smallest, okay, so this is n is our smallest one. So 5 times n is, okay, so that's our word that clues us in. That's where our equal sign goes. 5 times the smallest is equal to 7 more than, 7 more would be 7 added to, twice the largest integer. So this is my largest integer, so I need 2 times that. So now we have an equation that we can solve. And so first thing we'll do is we'll simplify the right-hand side with the distributive property. So we're going to get 7 plus 2n plus 8. And now I'll continue to simplify over here, so I get 15 plus 2n, and that's still equal to 5n. Now I can subtract 2n from both sides. So minus 2n and minus 2n. So that leaves us with 3n is equal to 15. So then if we divide both sides by 3, we end up with n is equal to 5. But we're not finished yet because we're told to find the largest integer, okay? So n happens to be our smallest integer. And if that's the case, if n is 5, remember we're dealing with consecutive odd integers, then our middle one must be 7, and our last one must be 9. So 9 is our largest integer. So 9 is the largest integer.